Now, remember, we're going to use NAT. I create a NAT here for all of these servers that are on this network here. And what NAT does basically is R1 is going to see these servers and is going to translate these servers from the public IP to the private IP. Okay? Now, here's a little bit of a trick. Number 5, when I go over NAT, there's 2 things you can do. There's 2 things you can do. You can NAT either on R1 or R2. Doesn't matter. Doesn't matter. But I want you to think about this stuff up here. If you put it on either router, you'll get it right, or mostly right. I want you to think of this from an efficiency standpoint. Save as much CPU as you possibly can. Okay? Save as much CPU as you possibly can in this domain. Now I'm going to show you how to do this on R1. Okay? And it will work. It will absolutely work. But I'm not saying that this is the right way. Okay? If you do it all on R1, you'll pass the lab, guarantee it. You'll get a passing grade. You'll get a good passing grade. Okay? You won't get 100%. All right? Necessarily. So, for those of you guys who are recording all of this, just remember what you're seeing on the video might not be true. See, I have to make it so that when it goes on YouTube, there's a disclaimer. All right, so I'm going to do all this on R1. So first off, I'm going to go ahead and write this ACL from number 9. Got about 15 minutes here. So R1. So I need to create an ACL. And it says create the ACL in R1, which is fine. So, IP access list extended. Do I tell it a name? Nope. So I don't care what you name it. I'm going to call mine filter. All right. Now I'm going to do my ACEs, my access control entries. All right. So A, allow SMTP from the internet to 192.168.50.25. Okay. But if I previously natted, if I already did a translation here, or even if I'm doing the translation somewhere else, here's the trick. What IP do I filter to? Got to remember, what's the traffic look like coming in the router from the internet? It's going to be public IPs, right? Public IPs. So I'm going to permit TCP anywhere, from anywhere, to a specific host. Here's the tricky part is, I gave you the private IP, but I need the public IP, 139. then I have to specify the destination port. So here's where I told you before, use a question mark. SMTP is, well, I can just use SMTP, or I could put 425. Either one will work. Boom, done. Second entry, this is where it gets confusing. Permit TCP TCP host 201.60.108.75. My BlackBerry server 125, which is 141. Host 201.68.109.141 and 141. All right, riddle me this, Batman. What service is the BlackBerry service? I bet you Google knows. For now, for instructional purposes only, I'm just going to set this at 10,000. Okay? For all of those you watching at home, 10,000 is not the BlackBerry service. If you put 10,000 in your lab, you're going to get it wrong. Okay, now that's on YouTube. You got to find out what those ports, oh, I let that slip in. Ports are. There's a couple of different ways you can do that. Allow web and secure web from the internet to .43. 2 entries. Permit TCP any host. Here's my web server. 43, which is 140. 201.68.109.140. EQ 80 or dub. They both work. Man, I hate writing access lists. So you know what I'm going to do? When I have a similar one, I'm just going to hit the up arrow. And instead of having to write that all over again, I'm just going to put 443.
What keys did you hit?
Up arrow.
Up arrow. Okay.
Yeah, that just saved me a good 30 seconds. Alright? Allow hosts on the workstation. Whoa, stop. Hold it. Time out. Allow hosts on the workstation network to access AD, but block them from accessing the ACS server. All right, let's look at the topology again here, kids. Again, I try to trick you. Allow hosts on the workstation network, where's the workstation, to access the Active Directory server, but block them from accessing the ACS server. I wouldn't do that on R1, would I? Why would I not do that on R1? Think about the traffic flow. The traffic is coming from the workstation network. It's going to the Active Directory server. Why in the world, why anywhere under the sun would it go through R1? Let's take a look at R3 again, shall we? And let's take a look at our routing table. Show IP route. So for traffic to get from this network, which is connected, so on that router, to get to the Server network via 130. It doesn't say via 129, does it? What is 129? Is it R1, R2, or R3? It's R1. That traffic's never going to touch R1, will it? Therefore, if you make an access control entry in R1, it's never going to be seen. So what does that tell you guys? You got to put an access list somewhere other than R1 for that entry. Somewhere other than R1 for that entry. Okay? I give you a few weeks for this for a specific reason, guys. It's like a puzzle. I like puzzles. I love my lab 2s, and as you guys who are in 471 will get to know tonight, you're going to hate me for the next 2 weeks. I like puzzles. Okay? I make you think about this stuff. Okay? This is going to make you a better network engineer. If you don't go into network engineering, fine. You have to understand traffic flow. It's going to make you a better security engineer. It's going to make you a better auditor. It's going to make you a better security consultant. It's going to make you a better business systems. Whatever field you go into, you understand how networking works. And don't think of it as dark magic. I know some of you probably think it is, right? Right? I get it. Okay? It has a logic to it. You just have to grasp it. All right? It works in a logical fashion. Packet A has to get through router B to get to destination C. How do I find that out? So I do that. Think about where the traffic is coming from. Think about where it's going to. Think about the process of how it has to get there. It has to hit a router. It's got to get routed. How does it get routed? Well, in this case, it's going to OSPF. How do I find out how it gets from this network to this network? Look at the routing table. I got to filter traffic. Well, if I know the traffic is going this direction, where's the best place to put that filter? Well, there's multiple places to put the filter. You're absolutely right. But there's a best place. Okay? There's a best place. You can put it somewhere and it'll work. Guarantee it'll work. But it won't work to the best efficiency possible. All right, just a couple more. We got to cut loose out of here, okay? So I'm going to leave that one for you for next time. Block all hosts from accessing 192.168.50.43 via SSH. Wow. All hosts means what? Anybody, right? Anybody. Okay. Couple different ways you can do this. And actually, this is an ACE that has to go in multiple access control lists. I can put it in my R1 ACE via deny statement. Deny TCP any host 192.168.50.43, which is 140. EQ. Oh wow, SSH isn't on here. This is packet tracer. What port is SSH, guys? 22. But I said deny should go where? crap, now he's got to go at the front end of an access list, doesn't it? All right. Well, we'll remember that in a second. Block all hosts from being accessed via telnet. NI, TCP, any, EQ, 23. We show run. All right. Now, I do a show IP access dash lists. See my numbers? Now, what can I do to move these two from 50 and 60 up to the top? Here's a trick, guys. Here's a trick. Okay, I can go back into that ACL. Sorry, IP access list extended filter. No, deny TCP, any, EQ, telnet. I can put a number in there before 10. 5, 9, TCP, any, EQ, telnet. Do show IP. Up arrow. See where it went? Again, would the access list work? Of course it will. Of course it will. Absolutely will. But there's a best practice. Can't drill that into your guys' heads enough. All right. We'll go over number 10 on Thursday and NAT on Thursday as well. Okay, and we'll finish up chapter 4. All right. Lab 2 isn't due for a couple of weeks, I don't believe. So we got some more time to work on it. Work ahead. I don't care. Do this up in Packet Tracer. Come on back. All right. And see how far you can get without me. Let me save it this time.